that you solve that particular problem, and if you are getting any problem, then in the demonstration time we'll help you. Okay, are you getting?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So all of you remember na which particular date my class is going on. Actually, I keep the record very strictly. Okay. So also from your side also, because physically you are not present, because this is the online mode, so record is very much important. Okay. So and I'm also very much strict about the attendance. So end of the semester, don't come, sir, why my attendance is less and all those things. Obviously you can come and you can check your attendance. Okay, because automatically attendance with me, and it is already when the class is completed, it is already generated. Okay, so don't come, sir, please, my attendance is very less, and because obviously your attendance is less if you are not attending the class regularly. So for that particular reason, don't come, don't come. Okay. And if you are checked your attendance, or you can ask about the attendance percentage and all those things, then obviously always yeah, from my side it is okay, no problem, you can check your attendance and all those things. So now mid semester is still still it is mid semester will conduct, okay, in the month of middle week of December or first week of January, I don't know. So I request all of you, please attend the class very regularly. Okay.
Sir, will it be offline or online?
Sorry, that particular part I don't know. It is totally depend on the government policy. Okay.
Yes, sir.
Now you
Yes,
know,
sir.
because many places again the pandemic situations are coming. So
Yes, sir.
and also we are very also we are, because if you people are coming, then physically interaction is very good for us, because you have any
Yes,
problem,
sir.
I will help you. But it is totally depend on the government policy. So and also university depend on the government policy. Okay. So university, because this is the central university, so we can follow the some particular central rule as well as the state government rule. So that particular part I don't know, but hopefully we'll expect then in the month of January or in the month of end of the December, it is going well. Okay. So
Okay, sir.
it is depend on that particular situation. If situation is very bad, then obviously it is the offline mode. But offline mode, you don't think like that. It is the multiple objective type question. Okay. So we are providing some particular question and all those things, and on the strict between the strict time, during the strict time, you can complete that particular answers. And most probably when you are giving the answer, your video is on something like that. Okay. So you don't yes, ऑनलाइन होगा तो ये मल्टीपल चॉइस क्वेश्चन होगा, हम लोग कोई प्रॉब्लम नहीं है, हम लोग फोन पे बात करके पूछ लेंगे. You don't expect like that. So from your side, you very honest, then obviously no one can interrupt you. Okay. Okay, then I will start my class.
Yes, sir. Yes, sir.
Tomorrow, no, yesterday I have some other exam, so I'm not able to take that class. So that particular class I will take on Saturday. Okay. So that particular message I have already forwarded to the WhatsApp group. So also you can check WhatsApp. And the one thing I am very strictly saying that don't distribute or don't share any personal information or something like that particular group. I am requesting all of you, only the subject related things just you can share. Okay. So particular number, yes, I'm getting this particular number, the exam will be conducted this date, the assignment is this one, I have already submitted that particular related to all the information which are related to this particular subject. Only that particular information you share in that particular group, WhatsApp group, and don't other message, please don't share. Okay, just a minute. No problem.
फोन काय करतो मग पापा
Screen is visible.
Yes, sir. Yes, sir.
Okay. So last class we are discussing about the sequential circuit. Okay. So sequential circuit already we have discussed about the LEDs, normal general LEDs. Okay. So different type of LEDs, and after that we are going to the clock flip flop. Okay. So what happened? LEDs and the flip flop is nothing but a one type of storing device. Okay, and storing element device. And if someone is asking you flip flop is what, one type of memory device, memory device which are capable to store binary information. It is either 0 or 1. Okay, and when we are talking about the flip flop, that time what happened, we are not using any particular clock signal. When we are using the LEDs, that time what happened, we are not using any particular clock signal. But when we are using the flip flop, that time what happened, we are using the clock signal. Okay, and the reason, in LEDs we are using the level sensitive. Okay, that means signal is coming. Signal is we can control from the level. Okay, and when we are talking about the flip flop, that means what? It is the transaction period. We can use the edge sensitive. So it is called a edge sensitive. Okay. So this particular part I think I have already discussed, and some parts are remaining left. So let's just, yes, this particular part also over. Okay, yes. So clock SR flip flop. So this one is the timing diagram. Okay, this one is the circuit diagram. Okay, and this one is what? It is the state table. It is not a truth table. Okay, any table if we are defining in sequential circuit, that one is called a state table. Okay, why it is called a state table? Because here we are using the present information and past information. No, sorry, past information also. That means memory. So it is no more truth table. So it is called a state table, and this is the behavior. And this particular behavior also we can represent it in this particular table. That means what? When S and R, that time what happened? What is the present state? The next state is same, value is same. Okay, so see here S equal to 0 and R equal to 0. What is the present state? Present state is 0. This one is 0. Okay, so what happened? What is the next state? Next state is also 0. So always remember, when S and R equal to 0, that means what? Next state equal to the present state. Okay, so here I am writing Q. But when S equal to 0 and 1, that time what happened? The output is always reset. Reset means what? It is 0. And when 1 equal to 0, that time what happened? This one is called as set. And when 1 1, that time what happened? There is no sense between the present input and the past input. Okay. But according to the flip flop, see here, if this one is Q, this one is Q, and always this one is the Q bar. Q bar means what? Q bar means nothing but a complement. If Q equal to 0, Q equal to 0, that time what happened? Q bar is always 1. Okay. But when we are applying S equal to 1 and R equal to 1, that time what happened? This particular output, it is not we cannot determine that particular output. Okay. So what happened? For that particular purpose, it is called an invalid state. We cannot determine anything when S equal to 1 and R equal to 1. And this particular condition is happen only when we are using the clock SR flip flop. SR means what? It is set and reset flip flop. But generally people are using only SR. Okay. And now see here. Now based on that, based on this particular diagram, we can find out the characteristics equation. Okay, we can find out the characteristics equation. So see here how we can draw the characteristics. So based on the flip-flop, we can draw this one. Okay. So how many variables we are using here? We are using here what? 3 variables we are using. So it is 8 variable KMF. Okay, it is not a 4 variable KMF. This one is called a 3 variable KMF. And you know how we can construct the KMF. So what happened? One is called a present input, that is defined by the Q, and then general input of this particular flip-flop is S and R. Okay, and this one we can define as a 0, and this one we can define as a 1. And this one is what? This one is 0, 0, and this one is 0, 1. Okay, and this one is 1, 1, and this one is 1, 0. Okay, so what happens? See here, when Q equal to 0 and SR equal to 0, that time what happen? This one is 0. See here, this one is 0. Okay, so because what happened? This why we are not considering here 0? Because we are using the sum of product from. So where the output is active, that particular cell we are activated. Okay, so see here, 1 0 0. 1 0 0 means what? The output is 1. So here we are putting here 1 0 0 1. Okay, and after that, see here 0 1 0. Which one is the 0 1 0? This one is the 0 1 0. The output is 1 0 1 0. This one is 1. Okay, and next one is what? 1 1 0. 1 1 0 is also 1. This one is the 1 1 0, and output is 1. Okay, so this one is 1. Now what you can see here, 0 1 1. 0 1 means what? Indeterminate. That means we don't know it is 0 or 1. So what happened here? We are applying the don't care symbol. Okay, and after it also what happened if present is present input also 0 1, S equal to also 1, R equal to also 1. What happened? This one also indeterminate state. So what happened here? We are using the don't care symbol. Now you can, after that what happened? Now you can easily construct the, you can easily extract the expression from this particular KMF. So how we can? So this one is one particular group. Why we are covering maximum 1? Because what happened? We are getting the minimum number of terms and minimum number of literals, because we are using within this particular group. Okay, so if we are using only one group, that time what happened? Maybe our literal or variables are more. Okay, and another one is what? This one. Okay, so what happened? So what we are getting Q equal to next state is T plus 1. This one is T plus 1. Okay, this one is T plus 1. So our expression is something like that. S, this one is S plus QR. Q R dash. So how we are getting this particular expression? So I'm not, you automatically know, because when we are considering this particular group, see here, 0 and 1 is cancelled, and the 1 0 is cancelled, only 1 1, and the 1 1 is representing S. So here this one is S. And next one is what? This particular corner, the lower down corner, see here, it is 1. So 1 means what? It is Q, because when the sum of product, that time what happens? 0 is complement and 1 is uncomplement. So here I'm writing Q, and after that, see here, 0 and 1 is cancelled, and only 0 is representing, and 0 is left, and 0 is representing as a R, and 0 means what? It is the complement from. So here I'm writing R dash. Okay. Now see, how this particular SR flip flop, actually we are showing the timing diagram. Okay, so see here, this one, just I am drawing this particular part here. Okay, see, you can draw this way. Okay, something like that. Okay, now next one, see here, this one is, and this one is, we can symbol like this, and this one is. This one. Okay. So this particular other parts. So So you can also check from your textbook. They are also explained, but conceptual purpose, just I am explaining this one. Okay. So actually, how this particular flip flop actually representing as a timing diagram. Okay. So this one, if we are considering, this one is the timing signal. This one, first one is the what? Timing signal, and this one we are considering as a SR. Okay, SR, and this one is Q. This one is Q. And Q bar means don't no need to draw the Q bar, because this is the opposite. Just if it is 0, that time what happen? If we are draw the Q bar, that time what happen? Automatically what happen? Complement form. Okay. So this one is 0, that time what happen? We can start from this way. Something like that. Just opposite. Okay. So this one is what? This one is the from 1 to 0. So this one is the low level. This particular part is called a low level, this particular part. And this particular part, see here, it is going from up direction. So that means what? 0 and 1. This one is the active signal, this particular part. Now, based on this particular timing diagram, see what? When, because this one is the positive, we are going from positive edge triggered, positive edge. That means what? We are only, clock is only operated when it is going from 0 to 1. Okay, so this one is, see here, it is clock. This one is the timing diagram. This one is 1. Okay, this one is 1 timing signal. This one is the timing, that we are counting the timing. So this one is 3, something like that. But we cannot use this one is 3, because what happened? When it is 1, that time what happen? It is going from 0 to 1. Okay. Again, next timing is started from 0 to 1, something like that. Now what happen when this particular timing signal is applied? See here S equal to 0. That means it is S is in the lower side, in the lower level. Okay, lower h. Sorry, don't use the level. Lower h. Okay, that time what happen? S equal to also 0. But after applying this one, that time what happen when S equal to 0? But remember R equal to 1. Why I am writing this? Because this is the timing. After timing, dot dot is the after timing. Here from some particular delay is there. This particular portion is the delay. But what happen if it is S equal to 0? That time what happen? R equal to always 1. Okay, you can automatically see from here when S equal to 0, then what? R equal to 1. And what is the output? Output is what? 0. So if we are considering this particular output Q, that time what happens? See here, this one is the output we are considering as a, suppose this is the timing diagram, so this one is 0. So this is the first timing diagram I have already told you. So this one is the lower part, lower level, no, lower edge. Okay, so this one is 0. Okay, and same case if we are applying the 1 and 1 0, you can consider this particular state table, then you can automatically understand. So when Q equal to 0 and S equal to 1 and R equal to 0 and Q equal to, that means what? The output is always present, output is always 0. Okay, that means what? 0 means what? After that we are clock signal, when the clock signal is active, that time what happen? These particular values are showing. Okay, so if you are comparing this particular table carefully with the timing diagram, then you can automatically understand. Okay, this particular timing diagram based on this particular state table, and how this particular state table is coming, and based on this particular circuit. Okay, this is called a clock SR flip-flop, and this one is called a block diagram. We can representing this way. Okay, so what happened? This one is clock signal, and there are two inputs S and the R. This one is the two output. So Q and Q bar. Q bar is nothing a complement of Q. Okay. Any doubt this one?
Sir?
Yes, please.
So S equal to 0 और R equal to 1
Yes.
and Q equal to 1 होने से वो क्या होगा? कि S equal to 0, R equal to 1.
Just a minute. S equal to 1 and
S equal to 0.
Okay. S equal to 0. Yes. After that?
R equal to 1.
Okay. After that, okay. S equal to 0 and R equal to 1.
And Q equal to 0.
Then output this one you are telling, na, this particular sequence when S equal to 0 and R equal to 1, obviously Q equal to 0. Q equal to 0 होगा तो Q bar क्या होगा? 1 होगा.
1 हो जाएगा.
हाँ. तो मैं पूरा टाइमिंग डायग्राम यहाँ पे नहीं दिखा रहा हूँ ड्यू टू शॉर्टेज ऑफ ये. So I am giving the concept. Just मैं एक का बता दिया. That means what? This one is what? This particular timing diagram when S value is what? But here S value is 0 because it is the lower level, na?
Yes.
Okay, and the R value is going high after applying this first timing signal. So this one is 1. So R1 S equal to 0 and R equal to 1. So you can check here in this particular timing diagram when S equal to 0. Suppose this one is 0 and R equal to 1. Okay, that time what happened? Q equal to 0. So here, so it is Q equal to 0. Okay, if Q equal to 0, then obviously Q bar equal to 1 because this is the complement. Q अगर 0 होगा तो Q bar obviously क्या होगा? Complement होगा. और Q equal to 1 होगा तो Q bar क्या होगा? 0 हो जाएगा. ठीक है? So Q bar, then if you are correctly draw the Q timing diagram, then obviously just you can opposite this particular signal, then automatically you can get Q bar complement. Okay.
Okay.
So next one is called a clock D flip flop. So what is D flip flop? मैं D का टर्म्स आप लोग को बोला था. क्या था? D का टर्म्स क्या था? Why we are using D? याद है आप लोग को?
Sir, delay.
Okay. Very good. So D means what? Delay. So shortly, no one can say that delay flip flop. Generally use the D flip flop. But so someone is saying that what is D? Why they are using D means what? This particular circuit, what happened? When one particular input going to the output, so for getting all the correct output, sometimes what happen, this particular circuit working like as a some particular delays occurred more. Okay, when it is going from input to the output. So basically what happen, we are using the D. And also obviously we are using one particular term, it is called a race around condition. That particular part is coming in the jacket flip flop. Suppose some particular part is toggle and something like that. So what happen, this particular, when we are using D flip flop, they are not actually occurred in the race condition, race around condition. Okay. Now see here, D is nothing but is a modification of SR flip flop. Okay. And see here, this one is the NAND gate. We are using different type of NAND gates. Okay. So here, if we are using, suppose this one, if we are using, this one is 1, this one is 2, sorry, this one is 2, this one is 3, this one is 4, and this one is 5. See behavior of this particular circuit. Okay. So when NAND gates 1 and 2 from a basic, this particular basic flip flop, this particular is the basic flip flop, this particular portion. Okay, this particular portion is the basic flip flop. Okay, after that what happened, and gate 3 and 4 modified into a clock SR flip flop. So 3 and 4, this one, this particular 3 and 4, actually we are using extra 2 NAND gate we are using to modify the SR flip flop. Okay, and the D input goes directly to the input and it is complement through gate 5. So what happened, when we are talking about the D flip flop, that time what happened, we are using only the one input signal, that is called a D. And this is obviously, this one is the clock signal. CK means what? It is the clock signal. And D obviously entered as an input to the NAND gate. The number is 5. This one, this particular gate. Okay. As long as the CP input is at 0, gate 3 and 4 have a 1 in their outputs. Are you getting my point? So when we are using gate 3 and 4, and the clock signal is active, that time what happen, always output we are getting the outputs, the value of the output inputs. Okay, so whatever the outputs are generated, the inputs are same. That means output and inputs are values are same. Okay. And D input is sampled during the occurrence of a clock pulse. If it is 1, the output gate 3 goes to 0. So when D equal to 1, that means if suppose here we are putting here 1, that time what happen? Gate 3, which one is the gate 3? This one. Then output is always 0. So if it is S equal to 1, then S bar. This one is the S bar, that means output is always 0. And switching the flip flop is steady state. And flip flop is steady, that means what? When we are passing again, what happen? This one is the 1. Okay. If it is 0, that time what happen? The gate 4, if it is 0, that time what happen? The gate 4 is always, it is also 0. And if it is 0, that time what happen? This particular portion is going this one. And obviously this one is the feedback part is there. Okay. So this particular design, you can carefully put the values. That time what happen? Whatever the input, the same input produced to the output. That means what? That is the beauty of the D flip flop. Suppose I am explaining how this one. See here, when clock is 0, that time what happen? Clock is 0 means what? Clock is not active. And whatever the value you can apply for D, that means don't care. Here I am using don't care means what? If you are applying 0 or 1, it is does not matter. If clock equal to 0, that time what happen? There, this Q is not showing anything. That means Q is remaining same, no change. Okay. If Q equal to 1, then also it is Q equal to 1. Obviously, if Q equal to 1, then Q bar equal to 0. If Q equal to 0, then Q bar equal to 1 when clock is not active. And whatever the value of 0 and 1, it is does not matter. But when clock signal is active, this particular 1, that means what? Clock signal is 1. If D equal to 0, that time what happen? Whatever D means what? Here input. This particular D is input. So input D is 1, and we can interconnect all the NAND gates such that the output is remaining the output is always same as it is inputs. Okay. See here, d equal to 0, d equal to 0, that time what happened? Q equal to 0. If d equal to 1, that time what happened? Present state Q equal to 1. So obviously you know when Q equal to 0, then Q bar equal to 1. And when Q equal to 1, then Q bar equal to 0. And if we are carefully draw this particular state table, then see here, this one, and this one is what? Here it is qt plus 1. That means what? It is the next state. T plus. Here. See here. So Q equal to just I'm writing in the binary encoded. That means sequentially we are assigning the binary numbers. So 0 0 0 1 1 0 1 1. So what is the input here? 0 1 0 1. So obviously what happened? The next state is always 0 1 0 1. This one is the next state. What is the present input? Here it is 0, then also it is 0. Here it is 1, then also it is 1. Here d equal to 0, then also next state is 0. Okay, that means what? The next state not always depend on the present state. So it is called a delay. Some particular delay is something like that. We are implementing the delay. The input is equal to the next state. Okay, so obviously here only we are using the one input. So this one is called a two variable K-map. Two variable K-map. So this one is what? 0, this one is 1, this one is 0, and this one is 1. And this one we are applying as a Q and D. Q, because we are using only the present input and input of this particular flip-flop. So this one is called a 1 and 1. And when we are grouping this one, that time what happened? What is the next state equation? Correct. This is called a characteristics equation. Okay. So this one is called a characteristics equation. Remember, qt plus 1, qt plus 1, and this one is called a, how we can write what we are getting? We are getting d. Yes, correct. So that means what? Present is in the next state always depend on the present input. Not depend. That means we can say no. That particular statement is wrong. Sorry, I am wrong. So actually, what happened? The next state equal to the input values, binary values. Okay, so we are getting this particular equation. Okay, and now what happened? You can draw easily the timing diagram. How we can draw the timing diagram? Just a minute. It is very difficult for me to draw the timing diagram. Sorry, this one. So we can now, suppose what happen, we can active this way. You can active anytime. This one, the suppose we are using the, when it is going from 1 to 0, that time what happen, we can active the clock. Suppose this one is the active portion. Clock is active. This one is the clock is active. So different timing diagram are there if you are going to the defined book, but you can follow only one. Okay. Otherwise, you have but if your concept is clear, then you can draw. You can draw easily. It is no problem. Now see here how you can draw this one, this one, this one, this one, this one, this one, and this one. Okay. And next one. Suppose here I'm drawing spaces. Okay, no problem. Just I'm draw this one this way here. So suppose if we are starting this one, you see here when clock signal is applying. Suppose we are applying the clock signal here. So here is here one. This one is the clock signal. And that time what happened? And this one, suppose we are assigning this one is D, and this one is Q. Okay. See here, D, this particular D is going down. That means what? This particular level is 0. This particular edge is 0, and this particular edge is also 0. That means what? We are getting input is 0 based on this particular equation. Input is 0, then this one is also 0. Now next one is, see here, this one after the applying that, this one is the delay portion. This particular part is delay when we are applying to the next signal. So we are applying to the next clock signal. That time what happened? So D equal to 1. So this one, this will equal to 1. And after this particular applying the second clock pulse, this one, this is the second clock pulse, suppose. So that time what happened? E equal to also 1. So it is maintaining the same logic value or binary value. So based on this particular, if you know the properly, if you know the concept of state table and this particular diagram, then you can draw the automatically timing signal. See here, here it is 0, this one is 0. After applying the clock pulse, and this one we are getting also 0. Suppose I am writing this one is the clock pulse, clock signal. So this particular part also it is 0. Okay, are you getting this one? Any doubt?
Yes, sir. Sir, sorry to disturb you. I have one doubt.
Yes, only ask only one. From one side you can ask. Okay. So other please off your microphone, and when he is completed, then please second one is please ask. Okay. Please.
Yes,
yeah.
Sir, just now you told us that the D in D flip-flop stands for delay. Sir, we found that it is for data.
Just a minute. It is
yes, sir.
Just a minute. Yes, keep. No, I don't think so. Data, because here from actually data means I don't know some particular book, but D actually delay, because the circuit is the circuit actually working with, because we are using the external AND gate. So what happen when propagate from input to the output, there are some particular delay time is there. Okay, the delay portion is there. So generally these we are using the delay, and data maybe they are using data. I don't know data about the data, because only one particular input signal, and input equal to the output. That means whatever input is associated, that particular value is going to the propagate to the output. So that way they are using the data maybe. Okay, but from my side, and I don't know, because delay. So I'm saying that data means what? They are saying that output equal to the input. Whatever the input we are using present state, that is the output. So that's way they are using D4 data. But D4 also delay is also correct. Okay.
Okay, sir.
And next question. Next one, someone is asking something.
No, sir, it's clear.
Okay. So this is called a D flip flop. Now, what is JK flip flop? Okay. So JK flip flop is refinement or regenerated from the SR flip flop. Okay. Actually, some particular book they are mentioning that a JK flip flop is refinement of SR flip flop, in that the intermediate state of the SR type is defined as a JK type. Okay. So because see here, what is the problem of SR flip flop? When S equal to 1 and R equal to 1, that time what happen? We are getting the indeterminate. That means we cannot determine that particular what is the exact output. Okay. There is very fast between the 0 and 1. Okay. So modifying that particular situation, we are using some particular JK flip flop. And JK flip flop also what happen, one particular condition, when J equal to 1 and K equal to 1, that time what happen? Toggle is occurred. Toggle means what? Either sometimes after few delay, that means automatically it is generated 0, and after that what happen? It is generated 1. So you cannot predict, that means same sequence you cannot get the unique output. Okay. So if we are applying the same sequence, sometimes you are getting 0, sometimes you are getting 1. So for that particular purpose, here we are using the word called a toggle. Toggle. Okay. So if you are carefully check this particular portion, because this one is the very familiar with you. This one, just a minute. This particular portion you have already know. So what happened here? See here, what is the this one? This particular part. This particular part we are connecting here. No, some particular problem is there. Sorry, here some, I don't know where. Maybe this is defined, but don't connect. Okay, this one is connect, but this one you can connect here, and this one you connect here. Okay, so Q is connected. Oh, sorry. Okay, no problem, no problem. Just a minute, It is correct. Sorry, I have some discard. Actually, problem is that this particular part you can very carefully you can check. Otherwise, what happen? Your whole diagram is wrong. I'm also confusing when checked it, because I'm downloading this particular diagram from the net. Okay. See here. Actually, normally what happen, if you are going to the normal textbook, that time what happen, instead of this one K, J. Okay. And this J, they are using K. That time what happen, this particular Q is connected to with K. And this one is connected with J. Is okay, no problem. But remember always one thing, when Q is always connected with K, and Q bar is always connected with J. If you are using instead of K here J, if you are writing J, that time what happen, please take care of this particular feedback connection of the input of J and K. Okay. For this particular, if I am writing K and J, this particular diagram is correct. But ये K को अगर हटाकर यहाँ पे J लिख देंगे और J को हटाकर K लिख देंगे, then this particular diagram is wrong. So you very careful about this one. Okay. Now see here. Here, this is what is the difference with the SR flip flop? The only difference between the SR and JK flip-flop is that the Q and Q bar outputs are feedback to the pulse of the NAND gates, string the NAND gates. This feedback connection is what gives the JK flip-flop is the toggle operation for J equal to K equal to 1. So what is the difference in SR and JK flip-flop? When SR, S value equal to 1 and R equal to 1, that time we are getting the indeterminate state. That particular state we cannot evaluate. We don't know. But if we are designing the SR flip-flop in this way, and this one is the what? This one is the OR gate. Okay, this one is the NAND gate. And some particular book, instead of NAND gate, they are using the NAND gate also. Instead of AND gate, they are using NAND gate also. Then that is also correct. Okay. So what happened when J equal to 1, K equal to 1, they are not showing the indeterminate state. They are showing the toggle. Toggle means what? It is race between the 0 and 1. एक बार 0 होगा, it is racing. 0 is racing with 1. And or vice versa. 1 is racing with 0. Okay. See here. This particular J equal to K equal to 1. Here, next state it is showing 1. What about a Q? Okay. What about a Q? Okay. But when we are using, again, when we are checking after view competition, when J equal to 1 and K equal to 1, that time what happened? This particular 1 is goes to the 2-0. So what happened? The same sequence, one time it is 1 and the one time it is 0. That's why this particular toggle concept is, so that means we are writing here toggle. Okay. Now see here, if applying this particular value, if you are applying in this particular circuit, you are getting this particular output. That means you are getting the next state out. But remember, your concept must be clear. This one is Q is, we are saying that it is the output of the flip-flop. But we cannot saying that this one is the present state or this one is the next state. Okay, maybe next state, what is the next state of this particular gate? Of this particular gate, next state is there, this one is the next state. So this way we are using the terms present state and next state. Next state is nothing a output. That means combination में जैसे हम लोगों ने use किया था, the circuit का जो output है, that this is called output. Is but here what happened? Yes, obviously Q and Q bar is the output of this particular circuit. But here in this particular Q, it is not representing this particular Q. Okay, this particular Q, when we are talking about the state table, this particular Q is a call a present state and QT. That means what? This one is the QT. Suppose this one is the QT. Okay, so QT in that particular present state, the Q value is 0, and after taking the value of J and K, what is the next state? This is the next state value. So here I am writing T plus 1. So QT plus 1 denoted as a next state and Q is a present state. Now, if you are applying this particular, all the binary sequence in this particular circuit, that time what happened? When J equal to K equal to 0, that time what happened? Here I am writing no sense. This particular circuit and this particular, the state table are both are same. It is equal. Okay. So when J equal to K equal to 1, what about the present state? Present state propagate to the next state. So here it is 0. So this one is also 0. So here I am writing if J equal to K equal to 0, that time what happened? Present state equal to QT. This particular next state equal to present state. So it is called a no sense. When 0 equal to 1, see how I am telling that 0, 0, because based on this particular circuit, you can carefully observe the value. Whatever the value is coming, that time whatever you are getting this particular term, this particular logic value. Okay. When J equal to 1 and K equal to 1, that time also what happened? We can getting the reset. Reset means what? Set means 1 and reset means 0. Here we are getting 0 and don't think like that here yes present state में zero है इसलिए zero क्यों नहीं लिखा ये तो zero दिखा रहा है नहीं this is not like that because this 0 1 in already occurred somewhere this see here 0 1 so when j equal to 0 and k equal to 1 and when j equal to 0 and k equal to 1 here it is 0 and this one is also 0 that means it is fixed so here I am specifically we are writing as a this one is a reset so here I am writing here reset reset means what 0 and here reset means what 0 next one when 1 j equal to 1 and k equal to 0 that time what happen it is set means what 1 so here it is 1 and somewhere else see here yes 1 0 this is also 1 so specifically we are writing set this one is called as set but when j equal to 1 and k equal to 1 that means what it is q bar this one is called a q bar it is 1 times 0 and 1 times 0. See here this one is 1 1 what is the present state 0 so complement is what 1 when it is 1 1 that time what happened the present state is 1 and this is the complement of this one is 0 okay so this is the state table of this particular jk flip flop and what is the characteristics equation how many variables we are using can you tell me in characteristics equation sorry in kmap
3.
yes correct
3.
yes so we are using the 3 variable kmap so you can easily find out this one so this one is what one is q and another is jk okay jk this one is 0 0 this one is 0 1 oh sorry here 0 1 and this one is 1 1 and this one is 1 0 and this one is 0 1 see here when 0 0 that time what happened the next state is 0 we cannot do anything when 0 0 1 that time also output is 0 but when we are considering 0 1 1 0 1 1 that time what happened according to the state table 0 1 1 is 1 so here I am writing 1 and when 0 1 0 then also output from the state table it is 1 so here I am writing 1 when 1 0 0 then also it is 1 but when 1 0 1 that means this one is 0 when 1 1 1 it is sometimes 0 and sometimes so it is we cannot you can don't use here don't care because don't care is I think not required here okay so this one is 1 1 1 0 means what this one is 1 and we can use this one because toggle is not a don't care okay so we are not using the don't care term but here it is one group how many groups are there it is two groups are there so qt this is called a characteristics equation of the flip flop jk flip flop so this one is what t and this one is plus 1 and this one okay so how we can write the characteristics equation this one is from the kmap here I am writing
qk plus q bar j
yes q bar j yes you can say that q k bar okay no problem q k bar yes correct you are correct so this one k bar okay now you can study that means from this particular state table how we can draw the timing diagram because timing diagram already I have discussed in D flip flop also SR flip flop so you please if any doubt then obviously you can ask me in the next class no don't hesitate okay now we are directly going to the T flip flop okay so T flip flop means what to overcome the T means what toggle T means what here this one is called
sir
just a minute here how it is screen is saying. Oh, this one is called a toggle. Just a minute. This one is toggle. Yes, please ask.
What is
Someone is
the use of toggle here? What will be significance of it?
the toggle. See here is going. Yes, it is very good. Yeah. So what happened? Actually, toggle is we are forcefully not applying the toggle. Okay. When we are designing the circuit, that time what happened? Based on that particular circuit, that toggle concept is coming. Now I have already told you why JK we are introducing. That means what? JK is the refinement. That means it is the modification of the SR flip-flop. But when we are using the SR flip-flop, then when S equal to 1 and R equal to 1, that time what happened? We are getting the indeterminate state. So to carefully check about that particular problem, we can designing such circuit like that. Anyhow, we can when S equal to R equal to 1, how we can overcome that one. That overcome means what? How can any modification is there and anything is possible. Okay, without that means without we are extending the our circuit. So in JK flip-flop, see here, this particular part is almost it is same as the SR flip-flop. Only difference is that this particular Q is connected to the K and Q bar is connected to J. So that means what? This particular feedback is connected to the input of J. And I have already told you the feedback connection obviously we are using in sequential circuit because this is the past information we can propagate. Okay. So when we are designing this particular circuit, that time also we can observe when J equal to K equal to 1, that time what happened? One time it is 1 and one time it is 0. So when it is coming, one time it is 1 and one time 0, that time what happened? This particular toggle is coming. Toggle concept is generated. So if someone is asking you why toggle is introduced, no, we are not introducing any toggle. Just to eliminate the S equal to and R equal to 1, we are designing some particular, we are modified the SR flip-flop, and after observing the SR JK flip-flop, that time what happened? J equal to K equal to 1, you see in this particular state table, this particular behavior of this, the toggle is generated. Are you getting my point?